Today we're going to have ourselves a very fun time looking at something called chemical equilibrium. As you remember from class, chemical equilibrium is all about a chemical reaction that can go both directions. There's a forward reaction rate that produces a product, and there's a reverse reaction rate that produces the reactants. And of course, the big question always is, where is it going to end up? Are we going to have mostly products, mostly reactants, or is it going to be a 50-50 mix? Now, the way we're going to demonstrate this is we want to get two 2-liter bottles. Those are going to be the things that are going to be representing our reactants, that's one bottle, and our products, which is our other bottle. So we got 2 bottles. You'll also want to have a pitcher of water, or you could have a third bottle that you're going to be using to fill up our initial reactant bottle. Now, what do we need to do to get this thing started? Well, it'd be a good idea to have your 2 bottles, clear it off so you get the label so it's easy to see what the water levels are. You'll want to have some handy drill, or you could just use like a Phillips screwdriver. That will work out fine also, but I like these things. Makes more noise and more powerful. In addition to that, you'll want to have something that you can cut your bottle with, and I've just got my cutting knife, so that works out well. You can use that just initially to cut this, so I'll show you that in just a moment, and a tape measure. And I should also mention one more thing, really important, lots of towels. What do we want to do here? Well, we're going to take our bottle, let's say our very first one, we're going to call this one the reactant bottle, and we're going to take our drill. You may want to have parental supervision with this. If this thing slips off of here, guess where it's going? You're probably going to find your hand or something like that. And I can tell you just from experience, that hurts a lot. Not a good idea. For our reactant bottle, we're going to take our tape measure, and we're going to measure 2 inches from the bottom. So I just kind of set that right there, and I'm going to take my little drill and go boom, 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 and go through it. That's going to be the reactant bottle. I'm going to take my second bottle. There's my second bottle. And I'm going to do the same thing, but now I'm going to do it with a 1-inch hole from the bottom. So again, we go ahead and do it. Lovely sound. And we're all set. So now we've got our holes drilled, or if you're going to use a screwdriver, just be careful. I would recommend, whether you're using the drill or the screwdriver, keep the top on. The reason is as you're pushing down here, you want to have some volume of air inside that's going to keep this thing from collapsing as you press down. Once you've got this thing drilled, that's step 1. Step number 2 is we're going to go ahead and we're going to cut off the top of this thing. So if I take this, it's kind of like that, and I take out my cutting knife, you may want to use this just to make the initial puncture. So boom, that goes, pop it right through. Then you'll take your scissor and cut that around just the whole circumference. So now what you're going to end up with here is going to be 2 bottles, both of them with the top removed, each one with a hole drilled in it at different levels. Again, 2 inches for the reactant bottle, 1 inch for the product bottle. Once you've got that all set up, there's a couple other things you'll need to do. Number 1, you'll need to get a couple of bowls or something to elevate both of these bottles above a certain surface. In addition to that, make sure you've got some towels, because no matter how hard you try, guess what? This stuff is going to be leaking somewhere, squirting somewhere, making a mess somewhere. How much fun is that? In addition to that, you may want to get some food coloring so it helps to highlight the water. Now, what are we going to be doing here? How does this work? Well, we're going to go ahead and take our bottle. So we take our original bottle right here. This is going to be our reactant bottle. And we're going to fill this thing all the way up with water, all the way to the brim. What is that going to represent? Well, we'll come back in just a few moments and tell you that part. But you fill it up, and in the process, you're going to also have styrofoam cups sitting down right below it. So as soon as you pour the water in here, guess what's going to happen? This water is going to come squirting out of this little hole, and you're going to have to catch it with the styrofoam cup. When you're done catching this cup full, as soon as it's a cup full, about 20 seconds if it's a small cup, then you're going to pour it into the second bottle, which represents the product bottle. As you start adding more and more water into that one, guess what? That one's going to start leaking. And you may want to have a second person also. That could also be part of your supplies here. Second person, that person's doing the reactant bottle over here, the other one's doing the product bottle. And you're going to be then taking this styrofoam cup that fills up and you're going to pour it back into the reactant. So the reactant cup goes into the product side, the product cup goes into the reactant side. All right, with that explanation given, we're going to go ahead and do the experiment and give you an idea how this all works. Are you ready? It's time for us to actually do the experiment. Remember, this is chemical equilibrium that we're looking at. We're going to begin right here with our two bottles. We'll call that the reactant bottle on the left-hand side. This is the product bottle on the right-hand side. We're going to take our water, which is colored orange, and we're going to fill up the reactant bottle. So what does the full bottle represent? Notice as that's being filled up, once that water reaches a certain level, now we have a stream coming out of it, and we're catching it with a styrofoam cup. What are we going to do with that cup? We're going to put that into the second bottle. What did we say that second bottle was? What is this illustrating when we think of a chemical reaction? We're still filling up a cup from that reactant bottle. What are we going to do with that? We're going to notice that a stream is forming on the product bottle. Notice two people are better than one. We're not losing too much of our reactant and product in the process of this. Now you can count 20 seconds for each one of these cups and transfer at the same time. Now, of course, that's going to depend on the size of your cup and the size of the hole. Other question to think about is why did we put two different holes in there in terms of one's at 2 inches for the reactant bottle and one is only 1 inch from the bottom for the product? What's going on there? Now watch the rates. Look at the rates with the reactant side versus the product side. There's two different ways we can think of chemical equilibrium. One is the rates are equal. The forward reaction rate, which is going to be from bottle 1 to bottle 2, is going to be equal to the reverse reaction rate, which is bottle number 2 to bottle number 1. That's one way we can measure once we've reached equilibrium. But there's another way that I want you to be focusing on also. Look at the levels in each one of these bottles. Remember, once we reach chemical equilibrium, the concentration of the reactants don't change any longer. And the concentrations of the products don't change either. So we reach a steady state. That will be the thing you're going to be focusing on. When is it where the levels in these two different bottles stay roughly the same? I'll let you watch this for a little bit, and this will give you a good overview of how you want to perform this at home. Well, I'm just wondering right now what it's like at your house. Are you mopping up the floor? How wet are those towels? It's kind of hard to catch this stuff. I talked to the kids in my classes just this last week and I said, wouldn't it be different if I told you that was hydrochloric acid inside of those bottles instead of water? I bet you wouldn't spill a drop. Anyways, when we think of chemical equilibrium, we're talking about the whole idea of the forward reaction rate equals the reverse. And once we have a steady state of our concentration of our reactants to our products, they don't change anymore, then we say equilibrium has been established. And we have three possibilities. We could have mostly reactants have been formed, mostly products, or an equal amount. What did you end up having? When you looked at those two bottles, did you see the levels were about equal, or was one slightly more or less than the other? Now, what would be one thing that would change or affect this? Well, if you think about those holes we drilled, if you think of the reactant bottle, we put that 2 inches above the surface. So you have the bottom of the bottle 2 inches up. When we think of the product bottle, we did it 1 inch up. Is that going to change the rate between those two bottles? Not significantly maybe, but at least a little bit. Well, I'll give you a little hint. Think about water pressure. Think of gravity pushing down on this column of water in each one of those bottles. If you have a lot of water in reactant A in this very first bottle and it's 2 inches above, think about it, you have only so much water above. The stream is only going to go so fast. But on the other hand, if we're looking at our product bottle and that's only 1 inch above, we have a taller column of water above, which means when it pushes down, it's going to push down with more force. So think about it. Which one of those two bottles should have had a faster reaction rate? And as a result, which one would you predict actually would have had a level maybe a little bit higher? With all that said, at least you didn't have to wear safety goggles this time. This was a wonderful visual demonstration of chemical equilibrium. Hopefully you're not going to be mopping up for too much longer.